Hi everyone. So here we are working on practice 4 for chapter 4. And this is question number 1. Um, so it says that the 4 diagrams in figure 4.38 show the graphs of 4 different straight lines, all drawn to the same scale. In each of them, C is a positive constant. So C is a positive constant. Copy the table and write the number of the diagram whose straight line corresponds to the equation in the table. So let's look at the equation. The first equation says y equals c. So notice that c is a constant, and they're asking us to identify the line y equals c. We can see very quickly that it has to be this one. This is the one where there is no x. That means that the slope is 0, which gives you a horizontal line. So y equals c is option 2. The next equation says minus x plus c. So c is always positive, as it said here in the original question. C is always positive. So we don't really have to worry about c. What's going to help us find the other equations is the slopes. So this one has a negative slope. So notice that number 1 has a positive slope. Number 1 has a positive slope. Number 4 also has a positive slope. So our only option is 3, which is the one that has a negative slope. And you can see that there's more or less the same distance from here to here than there is from here to here. And the slope is negative because it's going downwards. So this is option 3. The next one is y equals 3x plus c. We only have 2 options left, which are number 1 and number 4. Notice that the next equation is 1/3. So obviously this slope must be a lot larger. So this slope has to be much larger than this other slope, 1/3. So this has to be number 4, because number 4 has a steeper slope, as we can see. Very steep slope. And number 1 is the diagram number we have left, where we can see that this is a slight slope of about 1/3. Okay, so here we are ready to work on question number 2. And it says the following diagrams show 6 lines with equations in the form y equals mx plus c. So notice that this is the equation of a linear function, where m is our slope and c is the y-intercept. So it says that in the table there are 4 possible conditions for the pair of values m and c. Match each of the given conditions with one of the lines drawn above. Okay, so in the first case, we have the condition m, or the slope, is greater than 0. That means that the slope has to be positive. And c is also greater than 0. That means that the y-intercept has to be above the x-axis. So let's look at them one by one. So L1 has a negative slope. We see that it's going down, so that one does not work for us. L2 is also negative. L3 is positive, but the y-intercept is less than 0, negative. L4 is negative. L5 is positive. And this is our guy because the y-intercept is right here, and that's above 0. So the first one will be L5. Let's look at the conditions for the second case. M less than 0, so a negative slope, and C greater than 0, so positive slope. Okay, y-intercept. So let's look for the negative slopes with a positive y-intercept. So let's look at first case, negative slope, but the y-intercept is below 0, so that would be not the case. This one goes through 0, a negative slope goes through 0. This one doesn't work because it's positive. And here's our guy, L4. Why? Because the slope is negative. It's going downwards, looking at it from left to right, going down. And the y-intercept is right here, which is above the x-axis. So this will be line 4. Next case. The next case says that the slope is negative, m is less than 0, and the y-intercept is also less than 0. I think we already saw that case, and that was number 1. Notice that here the slope is negative and the y-intercept is less than 0. So L1. And the last condition, or the last one, says slope is negative and c equals 0. That means it goes through the origin. And we could see that that was L2. L2 would be the answer here. L2. Okay, so here we are with question number 3. And it says the straight line L passes through the points A, -1, 4, and B, 5, 8. Question A. Calculate the gradient of L. Okay, so A is to calculate the gradient. Now remember that the gradient is m in the linear function. So m, as you can recall, is equal to the difference in y over the difference in x. So basically, we need to subtract the y coordinate in B and the x coordinate in B from the y and x coordinates in A. So we would have 8 minus 4 over 5 minus 1. So this will give us 4 over 5 minus 1. That becomes a sum. So 4 over 6, which we can simplify into 2/3. B says, find the equation of L. Okay, so remember that y equals mx plus b, right? mx plus b. And we already have m, which is the slope we just found. So we can substitute m for 2/3. So let's do that. 2/3. And we're only missing b, but the value of b would be simple to find by simply plugging in one of these equations. Or sorry, one of these coordinates, I should say. So coordinate A or coordinate B. I'm going to use the coordinates in point A. So in point A, the coordinate is for y is 4. So we write 4 equals 2/3 times x, which is in this case -1, plus b. So now we can solve for b. So notice that this will be 4. Let's move that to the other side. Plus 2/3 is equal to b. And then from here we can sum this. Remember that we can change this into a fraction by multiplying 4 by 3. So 4 is really the same as 12/3, right? So 12/3 plus 2/3 is equal to 14/3. So b equals 14/3. And then we have our equation. So our equation for L is y equals 2/3 x plus 14/3. Okay, and then finally, for part C, it tells us that we have a point P that passes, or that the line passes through, and it's in the form of 8, y. So notice that they're giving us the x value, and they want us to find the resulting y value. So we have to plug in 8 for x. So therefore, y is equal to 2/3 times 8 plus 14/3. So this will equal 2 times 8 is 16/3. Okay, 2 times 8 is 16. So 16/3 plus 14/3. And notice that this equals 16 plus 14 is 30. So 30/3, and that equals 10. So y equals 10. Very well, so here we are in question number 4, and it says the diagram shows the line PQ. So here we have line PQ, whose equation is x plus 2y equals 12. So we can see that that's the equation, okay? The line intercepts the axes at P and Q, respectively. So part A, find the coordinates of P and Q. All right, so P and Q are really the Y and the X intercepts. So if our equation is X plus 2Y equals 12, then we can easily find the intercepts by substituting either X or Y with 0. So if we want to find the Y-intercept, in the y-intercept, x is 0. So let's find the y-intercept first. So the y-intercept, for the y-intercept, we have that x equals 0. So 0 plus 2y equals 12. Therefore, y equals 6. So that means that our y-intercept, or point P is going to be 0, 6. And then for the x-intercept, we do something similar, x-intercept. Well, for the x-intercept, we know that y equals 0. So this is going to be x plus 2 times 0 equals 12. Therefore, we can see that x equals 12. So that means that point Q is going to be 12, 0. Okay, for part B, they tell us that there's a second line, and the second line is x minus y equals 3. Intersects PQ at point A, find the coordinates of A. So remember that whenever we want to find the intersection between two lines, that can be solved with a system of equations. So let's make a system of equations. So we have x plus 2y equals 12 is our first line, and the one they have now is x minus y equals 3. Okay, so because this has two variables, we need to eliminate one. Notice that the easiest way to eliminate one would be by subtraction. So let's subtract the second function or line from the first one, because that'll eliminate x. So remember that this is going to change the signs on everything, right? So x will be now negative, y is going to be positive, and 3 will be negative, right? In the sense of elimination. So x minus x is 0, so we eliminate x. 2 minus y, or 2 plus y, that's going to be 3y. And then we have 12 minus 3, and that equals 9. Therefore, notice that y would have to equal 3. Once we have y, we can plug it in either this one, the first function, or the second one, and we can solve for x. So let's do it in the second one. So notice that we had that x minus y is equal to 3. So then let's plug in y here. So we got x minus 3 is equal to 3. Therefore, x equals 6, right? So that means that point A is going to be 6, 3. Okay, so here we are now with question number 5. A triangle, ABC, is created using the intersections of the lines x equals 0. Well, x equals 0 is the y-axis. Y equals x plus 1, and y equals 2x, as shown in the diagram. So this is the diagram. Now this one goes through 0, 1, so this is obviously y equals x plus 1, and this other one would be y equals 2x. Okay, so those are our two lines, and then the other one is the y-axis, as we can see here. So letter A says find points A, B, C algebraically. Okay, so point A is the y-intercept of y equals x plus 1, and that's obviously going to be 0, 1. point B lies on both lines, y equals 2x and y equals x plus 1. Notice that if we plug 1 in those, right, 1 for the x coordinate, the y coordinate will be 2 in either case. 1 plus 1 or 2 times 1, so that's going to be B. And then point C is obviously the origin, so 0, 0. Very well, now they ask us to find the lengths AB, AC, and BC. So length AB, for this we can use the distance formula. So length AB is going to be difference in x squared plus difference in y squared. So let's do 1 minus 0 squared plus 2 minus 1 squared. And this is going to be 1 minus 0 is 1, 1 squared is 1, so that's going to be 1, plus 2 minus 1, that's 1, 1 squared is 1, so 1 plus 1, this will equal square root of 2. Very well, now we need to find AC. So AC, you apply the same formula, the distance formula, and for AC, let's see, first we have 0 minus 0 squared plus 1 minus 0 squared, and that's going to be equal to the square root of 0 plus 1. That's going to be the square root of 1, which is 1. Now, obviously, we didn't really have to do this to find AC because we can see it right here. It's 1. Right there. Well, it looks more like a 7. So let's do that again. Rewrite that. And I'm going to rewrite it as distance 1. Finally, we need to find length BC. So BC, and for this one I do need the Pythagorean theorem or the distance formula. So BC is going to be 1 minus 0 squared plus 2 minus 0 squared, and that's going to equal 1 plus 4, square root of that, okay, and that's going to be square root of 5. So here we have the three distances. We have AC, which is 1, AB, which is square root of 2, and BC, which we saw is square root of 5. Okay, so for part C, they want us to calculate the angle ACB. ACB. So that's this angle over here in this corner. Now, because we have the three lengths, we can use the cosine rule for this, right? So remember that the inverse cosine of an angle in any triangle is going to equal the side lengths that are next to it squared. So that's going to be 1 squared plus square root of 5 squared minus the opposite length squared. So that's going to be square root of 2 squared, and this over 2 times A times B, right? Or the two lengths that are next to the angle that we want to find. So let's plug this into the calculator directly as one expression. That way we can get a more approximate answer to this. So let's pull out the calculator. Okay, so here's our calculator, and we're going to do the inverse cosine of that expression. So for that we need second inverse cosine, and here we have to be careful with the parentheses. So let's do a parenthesis for the numerator. Okay, so parenthesis 1 squared, that's just going to be 1, plus square root of 5 squared, that's going to be 5, minus square root of 2 squared, that's just going to be 2. Okay, close parenthesis, and we're going to divide that by 2 times 1 times, I really don't have to write one, but that's okay. 2 times 1 times square root, second function, square root of 5. And then we need to close parenthesis and close it again. There we go. So that would be, let's check, 1 plus 5 minus 2 divided by 2 times 1 times square root of 5. And we're doing the inverse cosine of that. So we enter that. And that gives us, oh, this is in radians and we want degrees. So we need to go to the mode and make sure that we have degrees and not radians. So let's go here. And we should have this in degrees. Let's go back to the main screen. And I don't know how to grab that again, so let's just do it again. So this would be inverse cosine again of parenthesis 1 plus 5 minus 2 close parenthesis divided by parenthesis 2 times 1 times square root of 5. Notice that I'm omitting the 1. So square root of 5. Very well. Let's close that parenthesis and close the final parenthesis and hit enter. And there we go. This is now in degrees. And that is the measurement that we need here. So this is approximately, let's write it down here. Let's say 26, approximately 26.50, let's round it a little bit, 57 degrees. 26.57 degrees. Okay, I'm going to hide the calculator now. And we have that. So that's angle ACB. Next, and finally, I should say, finally, for part D, they want us to find, hence it says, notice it says hence, that means that we need to use the previous information. Find the area of ABC. So for this, we can use the formula for the area of any triangle using an angle and the two lengths that are next to the angle. So this would be 1/2, remember that's the area, 1/2 times A, or 1, times B, or square root of 5, times the sine of the angle, or the sine of C. So in this case, sine of 26.57. That would give us the area. So the area is equal to approximately, for this we will need the calculator again. So let's go get the calculator. Okay, so first we're going to clear this. And here we go. So we want to go 1/2, or 0.5 times 1, which we're going to omit, times square root, so second function, square root of 5, times sine of 26.57, 26.57, close the parenthesis, and this equals 0.5. So the area is approximately 0.5. So let's write that down. Need the pen. So here we go. The area then is approximately 0.5. And that would be the final answer. Okay, so now we're going to work on question number 6. Number 6 says a student has drawn two straight lines, graphs L1 and L2, and marked in the angle between them as right. So he's marked this angle here as a right angle. Now this looks kind of crooked, no, doesn't it? I don't think that's a right angle. So let's see what happens here. The student has drawn one of the lines incorrectly. Okay, which one, I guess? So it says consider line L1 with equation. So this is L1. I can tell because of the positive slope. Y equals 2x plus 2. And line L2 with equation. Y equals negative 1/4 x plus 1. Write down the gradients of L1 and L2. So that's A, using the given equations. Okay, so here the gradient of L1 is obviously 2, and the gradient of L2 is obviously negative 1/4. Okay. Which of the two lines has the student drawn incorrectly? Okay, so here we could really argue that either line is drawn incorrectly, right? Because we could just change the first line and move a little to the, increase the slope by 2, make it 4, and then we would have a correct line, or in this case, reduce this slope, or no, increase this slope as well for L2. So, which one is incorrect? That's a matter of perspective, but in the book itself, they tell us that the second line is incorrect. So this would be the incorrect slope. How can you tell from your answer to part A that the angle between L1 and L2 should not be 90 degrees? Well, we can tell that by looking at the drawing, but besides that, remember that when two lines are perpendicular, the multiplication of their slopes or gradients, so M1 times M2, should equal negative 1. All right, now we can obviously see that if we multiply 2 times negative 1/4, that is going to equal negative 1/2, which is not negative 1. It's wrong by a factor of 2. So, what would be the correct gradient? Well, the correct gradient for the second line should be negative 1/2. Why? Because negative 1/2 times 2 will equal negative 1. And then it says, draw the correct version of the incorrectly drawn line. So to draw the correct version, basically we just have to change the slope here a little bit and make it more like a gradient that would actually make a right angle with this. I don't have a ruler here, so I do it manually. What would be the equation of that new line? It would then be y equals negative 1/2 x plus 1. Very well. So here we are on question number 7. I'm going to move this here a little bit so we can see better. So it says a projector is mounted on a vertical wall, AB. So this is our vertical wall, AB. The beam of light from the projector makes an angle of 20 degrees right here, an angle of 20 degrees at A. The light makes a circle with a diameter of 9 meters on the horizontal ground, as shown in figure 4.40. The distance from the projector to the closest point on circle C is 12 meters. So this is 12 meters. I mean that this line here, this dotted line here, is 12 meters. The distance between B and C, it's 10 meters. So this is 10 meters here. Okay. So part A says find angle CDA. So angle CDA. So angle CDA is this one. Remember that when we want to find out what angle they're talking about, it's that letter in the middle is the key. We go from point C to D, that's the angle or the vertex, A. So CDA is this angle here. And they want us to find that angle. So how can we find that angle? Notice, let's look at what we have. We have the adjacent side to the angle, which is 9 meters. We're missing one side length. Once you're missing a side length, you can't use the cosine rule. So we're going to have to think about the sine rule. And I think we can apply the sine rule because notice that we have the side opposite to the angle, and we have opposite to the angle we're looking for, and we have also the side that is opposite to the 20-degree angle. So we can say that sine of 20 degrees over 9 meters is equal to sine of, let's just call it d for now, sine of d over 12, the opposite side. Therefore, let's use it here. Let's go over here. Sine of d is equal to sine of 20 degrees times 12 over 9. So d, or the angle CDA, would be the inverse sine of this, right? So let's do that on the calculator, and we will find the angle. Okay, so here we have the calculator, and we're going to find the angle CDA. So we said that we need the inverse sine, so inverse sine of sine of 20, let's close that parenthesis, remember that, times sine of 20 times 12 divided by 9. Now we don't really have to put all this other stuff in parentheses because this is just going to multiply it from left to right and then divide. So sine of 20 times 12 divided by 9, close that, and this is the inverse sine of this, and it's going to give us 27.13 degrees. So let's write that down. Let's write this down, and angle CDA is going to be 27.13 degrees. Very well, so here we are with part B of question 7, and it says a 2-meter high wall has to be erected between B and C. So this is the wall right here, the 2-meter wall that needs to be erected between B and C. Find the furthest point from B. So what is the furthest point from B, right, at which this wall can be placed without blocking the light? So that means that it has to not go higher than point F here. It cannot go any higher than point F. And then it says, give your answer to the nearest meter. So basically, we need to find out this distance here. Very well. From the previous question, from part A, we found that this angle here on vertex D is 27.13 degrees. And we're going to need to use that because we can find out the measurement of angle, this angle here, ECF, very easily. How so? Well, look. If you look at this angle here inside the triangle, let's talk about this one over here inside the triangle. If you look at that angle has to be whatever is left from 180 degrees after subtracting these two other angles, the 20 degrees and the 27.13 degrees. So if we add those, so 20 plus 27.13, that's going to equal 47.13 degrees. So these two angles added are 47.13 degrees. So this other angle here, C, has to be 180 degrees minus that. What that implies then is that angle C has to be also 47.13 degrees because this plus this angle here, ECF, will have to be 180 degrees as well. So then we already know what this angle measures. So angle ECF has to equal the sum of those other two angles in the triangle, which is 47.13 degrees. And this is what we need to use to solve this problem, because if we take triangle ECF, so let's label it here as ECF, we have a right angle because this is a wall, and walls have to be built straight up, perpendicular to the ground, so this is 90. We already know that this angle here has to be 47.13 degrees. And we also know that the height of the wall is 2 meters. So basically we need to find EC, length EC, because then length EC will tell us how far away from point B this wall will be built. So we can use a trigonometric function here. Notice that if we think about tangent, which is opposite over adjacent, tangent of 47.15 degrees is equal to 2, the opposite side to the angle, over the adjacent side, which is length EC. So that means that EC, or length EC, is equal to 2 divided by tangent of 47.15 degrees. So we're going to plug this into the calculator and see what that would give us. So let's bring up the calculator. There. So we need to find out what tangent, or what 2 divided by tangent of 47.15 degrees is. So we go 2, oh whoops, I can't use that. I need this other thing. So 2 divided by tangent of 47.15 degrees. And that is equal to 1.85. Okay, so then that means that EC, length EC, let's write it over here, EC, length EC is equal to 1.85. So let's write that as 1.9, let's round it, 1.9 centimeters. Okay, so let's go back to the problem. Where is it? There. So we go back to the problem, and we have that EC, length EC, which is this one over here, is 1.9. 1.9. Now notice that makes sense because this angle is almost 45 degrees. It's 47.13 degrees. So you know that you had to have something a little bit close to 2 meters here. Now a little bit less than 2 meters because the angle is a little more than 45 degrees. So this makes sense. Now, what is going to be then the answer? Because they're asking us the furthest point from B at which this wall can be placed. So what is BE? So BE is simply going to equal 10 minus the length we just found, which is 1.9, and this equals 8.1. But they say give your answer in the nearest meter. So that means that BE in the nearest meter would be 8 meters. Very well, so here we are with question number 8. A room is in the shape of a cuboid. It's just a fancy name for box. Its floor measures 7.2 meters by 9.6. Okay, and its height is 3.5. Part A, calculate the length of AC. So the length of AC is this diagonal over here. Let's try to draw it. There we go, AC. Now calculating the length of AC is not that hard. You guys can recall this from previous problems because at B, you have a right angle. So let's just draw the triangle over here. So you have something like this. So if this is A, this is B, and this is C, they want us to find AC, but we have a right angle here. So this is a right triangle. And we know that AB is 7.2 and that BC is 9.6. So we're doing letter A, 9.6. Therefore, AC is a hypotenuse. So AC has to equal the square root of 7.2 squared plus 9.6 squared. So we're going to need the calculator to do this. Okay, so here's a calculator and we're going to find the length of AC. So AC is equal to the square root of 7.2 squared plus 9.6 squared. So 9.6 squared. And that equals 12, exactly 12. Okay, so we're going to write the length of AC here, and we see that it is 12. Oh boy, I can write something better than that. Those are nice. 1 and 2. Oh, beautiful. 12. Okay, so AC is 12. All right, let's move on to the next part of this thing. And that's part B, which says calculate the length of AG. So AG is another diagonal. But AG is a diagonal that we can see in the drawing here. It goes from this vertex to that vertex. So this is a triangle that is actually standing up, so to speak, but it's also a right triangle. So we have this here. Notice that we can draw that. Let's draw it over here. So this is B. We can draw that as a right triangle. Notice that its base is 12, which is the length we just found. Then the height would be 3.5, and we need to find the hypotenuse again. Why so? Well, because this is A, this is C, and this is G. And they want us to find AG. So AG is equal to the square root of 12 squared plus 3.5 squared. So this is going to require the calculator again. So let's go get it. And let's do it then. So square root, whoops, I need the pointer. So square root of 12 squared plus, we said 3.5 squared. So 3.5 squared, and that equals 12.5. So let's write that down, 12.5. Actually, let's go back to the main screen and write that down. And that is going to be 12.5. So that is the length AG. Now it says calculate the angle. So C is calculate the angle that AG makes with the floor. So notice that that angle that AG makes with the floor is this one over here, because this is the floor, AC is the floor. And this is 12.5. So to calculate the angle, we have all three side lengths. Remember that implies using the cosine rule. So let's think about inverse cosine of 12 squared plus 12.5 squared minus the opposite side squared, 3.5 squared, and all of this divided by 2 times 12 times 12.5, and we're going to do the inverse cosine of this. So this would be approximately the angle. Let's go get the calculator again. And let's plug this in. So we need to do the inverse cosine. So second function inverse cosine, and here we will need those parentheses. So parenthesis 12 squared plus 12.5 squared minus 3.5 squared, close parenthesis, divided by, open parenthesis, 2 times 12 times 12.5, close parenthesis, and equals. And there we go, 16.26 degrees. So let's write that down. So that's going to be 16.26 degrees. So let's write it down. The marker, 16.26 degrees, and that would be the end of this question. Very well, so here we are with problem number 9, and problem number 9 says that figure 4.41 shows a triangle ABC in which angle BAC is 30 degrees. So BAC, this over here, is 30 degrees. BC is 6.7 centimeters, and AC is 13.4 centimeters. A, calculate the size of angle ACB. So they want us to find ACB, which is this angle here. Okay, so notice that we don't have all three sides. We do have an angle on its opposite side, so that means we're going to have to use the rule of sine to do this. And we're going to have to find angle ABC first. So we need to find angle ABC first. So notice that sine of B, let's just call it B, sine of B over 1 or over 13.4 has to equal sine of 30 over 6.7. So this implies that the inverse sine of sine of 30 times 13.4 divided by 6.7 is actually going to give us angle B. So let's find angle B first. So in order to find angle B, we have to do the inverse sine of what we got there. So second function to give us the inverse sine of sine of 30, which is 1/2 as we know, but we'll just write a sine of 30, that's okay, times 13.4 divided by 6.7. And we need to close the parentheses there. And this is going to give us 90. So that means that B is 90 degrees. So let's write that down. Angle B is then equal to 90 degrees. Therefore, B is 90 degrees. So because B is 90 degrees, and let's write that down over here. So B is 90 degrees, and this is 30 degrees. That means that this here has to be 60 degrees. Therefore, ACB is equal to 60 degrees. Okay, now, so for part B, they ask us to calculate the percentage error in Nadia's measurement of BAC. Why? Because Nadia makes an accurate drawing of the triangle, and she measures triangle BAC to be 29 degrees, but BAC is 30 degrees. So remember that when we want to calculate percentage of error, is equal to absolute value of the actual value minus the estimated value divided by the actual value times 100. Okay, so in this case, the actual value is 30. So absolute value of 30 minus the estimated value, which is 29. That divided by 30 times 100. So that would be actually 1 over 30 times 100. So let's bring out the calculator for that. And let's put it in there. So it's going to be 1, right? 30 minus 29 divided by 30. And that answer times 100. And that is going to be 3.33%. So that is equal to 3.33% to 3 significant figures. Very well, so we are on question 10, which is going to be the last question on this video, and also the last type of question that you will need to study for our coming quiz. Question 10 says, Jose stands at 1.38 kilometers from a vertical cliff. So this is Jose's distance from the cliff, which is obviously going to be this line here that is perpendicular to the ground. Therefore, it forms a right angle. That's very important. Letter A, express this distance in meters. Now remember that there's 1,000 meters in a kilometer, so we have to multiply 1.38 times 1,000, and that is going to give us 1,380 meters. Part B says, or before part B, it says, Jose estimates the angle between the horizontal and the top of the cliff as 28.3 degrees. So he calculates this to be 28.3 degrees and uses it to find the height of the cliff. So B now says, find the height of the cliff according to Jose's calculation. Express your answer in meters to the nearest whole meter. So that's very important. They want us to round it to the nearest whole meter. Okay, and they want the answer in meters, but we already have the information in meters, so we can use that. Very well. So look, let's label this as x. So this is a typical tangent function, right? Because we have a right triangle, so we can say really that tangent of 28.3 degrees is equal to x opposite over adjacent over 1,380. Therefore, we can say that x is equal to tangent of 28.3 degrees times 1,380. So we will use the calculator to find this. And we have to round it to the nearest whole meter. So let's see what we get there. So this is going to be tangent. So tangent of 28.3. Make sure you close the parentheses after this. Times 1,380. So 13 and 80. And we enter. And that's going to be 743 meters. 743 meters. So let's write that down. So this is 743 meters. That would be the height of the cliff, rounded to the nearest whole meter. Okay. So let's go now to part C. The actual height is 718 meters. So our calculation is off by a line, right? Because the actual height is 718 meters. Calculate the percentage of error. So again, letter C is percentage of error. So let's just do absolute value of 743 minus 718, which is the actual value. And this divided by 718 times 100. And this will give us a percentage error. So let's go back to our calculator. And let's go 743. So 743 minus 718. And that equals 25. So 25 divided by 718, which is the actual value. And that times 100 times 100 gives us a percentage error of 3.48%. So we're going to write that down. So that is going to be a percentage error of 3.48%. But we write it as 3.5%. Well, no, we can write it in three significant figures. Yeah, 3.48% is then the percentage error in this question. 3.48%. And that would be the end of this video. So best of luck to everybody. Send you all hugs.